Hi. Okay, so once again, let me do section 1.3 together with 1.4, okay? Section 1.3 now discusses the definition of a function. Section 1.3 is the definition of a function, good class, okay? And let me give you the definition of a function. All right, so I gave you the definition of a relation. Let me ask you, what is a relation? If you're walking on campus and someone comes to you and says, hey, Buster, what's the definition of a relation? What are you going to say? Your answer is going to be, a relation is a collection of ordered pairs. That's a relation. Once again, a relation is a collection of ordered pairs. Okay? And the reason we call them relations is because, well, usually the numbers in the ordered pairs are related. For example, okay? For example, watch this. Y equals 3x plus 1. Okay. Watch this. Let's find ordered pairs. Let's find ordered pairs for this. Watch this. If x is 0, what is y? Y is 1. And from here we get an ordered pair. 0, 1. Again, if x equals 1, what is y? 4. And from here we get another ordered pair. Right? Okay. If x equals -1, what is y? 1. What's 3 times -1? -3 plus 1, -2. Y is -2. And here we have another ordered pair. -1, -2. Okay. Another one. If x equals to 1/3, what is y? What is y? Y is 2, right? Because 3 times 1/3 is 1. 1 plus 1 is 2. X is 1/3. And what is y? 2. And we can do this forever and ever. Okay? I can do it again. And again and again. We're going to get old. Yes, we're going to get old. And then we're going to die, and we still will not finish finding point that satisfies this. And we're getting a collection of ordered pairs. Look, and it's infinite. This goes on forever and ever. And those two are related. Yes, they're related. I didn't pick them at random, or I picked one of them at random. I said x is 0, but then we got a y equals 1. They are related. That's what we call this a relation. Because those two numbers are related. Okay, these are related with this equation. So this is a relation. relation. They are related. Okay. There's a rule. And here's the rule. The rule says this. Where is it? Let me find it first. It's on page 35. And I call this the function rule. Page 35. It says, a function is a relation. A function is a relation. And what is a relation? A collection of ordered pairs. You must have ordered pairs in there. If you don't have ordered pairs, it does not qualify as a relation. But it says a function is a relation in which each element in this pair, each first value is paired with only one second value. That's the first value in the order pair. That's the second value in the order pair. So a function is a relation in which each first value in the order pair is paired with exactly one value, one second value. Okay? The way they say this is like this. A function is a relation in which each element in the domain corresponds to exactly one element in the range. Okay? So here, this value can be paired with only one y value. This domain, the collection of the first number in the order pairs is the domain. Okay? A function is a relation in which each x value is paired with only one y value. Okay. Each x value is paired with only one y value. So here, this 0 is paired with 1. This 1 is paired with 4. This -1 is paired with -2. No, that's the pattern. This 1/3 is paired with 2. So they're saying a function is a relation such that each x value is paired with only one y value. If an x value is paired with two different y values, it's no longer a function. It continues to be a relation. Okay. So therefore, a function is a relation in which each x value is paired with only one y value. Okay. All right. It seems to me that this is a function, because no matter what you plug in for x, that x value is going to be paired with only one y value. You give me a number. What number do you want to give me? You want to give me 1.2? Okay. Let x be 1.2. Watch what happens. Let x equals 1.2. Plug it in there. What is y? 3 times 1.2 plus 1. Okay? And what is y? 3 times 2 is 6. 3 times 1 is 3. That's 3.6 plus 1. So therefore, what is y? 4.6. When x is 1.2, y is 4.6, you see? And this 1.2 is not paired with any other y value except 4.6. So therefore, when x is 1.2, what is y? 4.6. You can do it again. You're going to realize that each x value is paired with exactly one y value. That's what's happening. Okay? So this is a function. This is a function. Okay? And this function is right here. And all the x values, we call them what? The collection of all the x values, what do we call it? Collection of all the x values. We call it the domain. So what's the domain for this function? Domain is all real numbers, right? All real numbers. R. That means all real numbers right there. If you say 0, you can't just say 0, 1, and -1. No, you have, remember, if you can plug in -0.5, you can plug it in there if you want to for x. This is x, and this is y, and you're going to get a y value. If you are. Try it. X equals -0.5. What is y? 3 times -0.5 plus 1. What's 3 times 5? So this is 15. So this is 1.5, right? 1.5, and it's negative plus 1. Okay? What's negative 1.5 plus 1? This equals to -0.5. Hey, look at that. Nice. So when x is -0.5, y is -0.5. That's a weird one. Okay, did I do that right? 3 times 5 is 15. Takes 1. 3 times 0 is 0, plus 1 is 1. That's -1.5 plus 1 is -0.5 for y. So this x -0.5 is paired with what? -0.5. And you can do that forever and ever. So here you can plug in any x value. It'll work. So that's why the domain consists of any number, any real number. What are you going to get? You're going to get y. Okay? And in y, you also here you get -0.5. Look, 0, -0.5. For paired with this x value. Okay. There you go. So therefore, the domain of all the x values is R. What about the range? The range are all the y values. The y values is the range. You're going to get negatives. You're going to get negatives. Look, you get positives. You're going to get R. R real numbers. Okay. Yeah. And so therefore, the definition of a function is a function is a relation such that each first component in the order pair is paired with only one second component, not with two. Okay. Here's another example. Okay. So, oh, by the way, one more thing I have to say. y equals 3x plus 1, I think. Yes. So once you know that this is a function, then you change this notation. You change notation, you change the y. You say this y now becomes f of x. F of x equals 3x plus 1. And watch this. You see this x equals 0? You're going to get 1? Well, now you can say f of 0. And it's 3 times 0 plus 1, which is 1. You see? You plug in this x value, and f of 0 gives you the y value. Okay? How about this one? You plug in -1, you better get -2 for y. So f of -1 equals to what? Well, 3 times -1 plus 1. And what's 3 times -1? That's -2. -2 plus 1? I'm sorry, -3. 3 times -1 is -3. What's -3 plus 1? That's -2. There you go. Okay. So f of -1 is -2. You see, -1 gives you the y value. Okay. You can graph this if you want to. Yep, you can graph this if you want to. All right. Let's graph it. We're going to graph f of x equals 3x plus 1. Okay. You're going to see all the x values in the graph, and you're going to see all the y values in the graph. Yes, you are. Okay. So for example, let's graph this. I'm going to make a table. The table is already there, except that you can make a table. You see this? Here's x, and here's f of x. When x is 0, f of 0 is 1. When x is -0.5, f of -0.5 is -0.5. When x is 1, you get 4. See that? When x is -1, you get -2. When x is 1/3, you get 2. Okay? So I have all of this right here. Okay? I'm going to erase this now. Okay? Because it's right here. But I'm going to graph it. I'm going to graph this function right here. Good class. So here's the x value. And now we can call this f of x. This is f of x. Okay? And so therefore, when x is 1, note, this order pairs come from this function or this equation. And now we're gonna connect all the points, because this is no longer a scatter plot. This comes from an equation. Okay, x equals 0, we get 1. X equals -0.5, you get -0.5. -0.5. -0.5, you get -0.5, right around there. X equals 1, we get 4. X equals 1, we get 1, 2, 3, 4. We get 4. Okay. X equals -1, we get -2. X equals -1, we get -1, -2, right there. We get a line. X equals 1/3, we get 2. X equals 1/3, we get 2 right there. And we're getting this line. I missed it. There. And there's your function right there. It's a function. Note, when you look at the graph, You're looking at all these order pairs. Yes, you are. You see this order pair 0, 1? When x is 0, y is 1. This point right here is 0, 1. When you see the graph, you see all the order pairs, and you also see a pattern. You see this negative 0.5, negative 0.5, that's right there. Right there. This is negative 0.5, negative 0.5, and it is an order pair. You see this negative 1, negative 2? It's right there. Negative 1, negative 1, negative 2. It's right there. You see, in this line consists of all the other pairs for this function. And you can tell by looking at this line that, for example, if x is, watch this. If x, that's negative 1, negative 2. If x is negative 2, y is going to be, this height is going to be negative. Okay? If x is negative 2, y is going to be, or the order pair is going to be there. This height, and it's going to be negative because it is in the first quadrant, second quadrant, the third quadrant. Okay? To find out for sure, plug in negative 2 for x into the function. Plug in f of negative 2. F of negative 2. What's 3 times negative 2? 3 times negative 2 is negative 6. Negative 6 plus 1. This is negative 5. So you see this order pair? The order pair, negative 2, negative 5, is a point on this graph. Okay? So it seems to me that for any x value, there is a y value. Only one. For this negative 2, there's only one y value, and it's right there. This height in the negative direction. Okay? Watch this. This is 1. This is 2. When x is 2, for x equals 2, y is going to be up here. So for every x value, there is a y value, and it's unique. For this x equals 2, y is going to be up there. For x equals 2, y is right up there. For x equals negative 3, y is below, because this line goes down forever and ever. Goes down forever and ever. Okay? So you can tell by just looking at the graph that for any x value, there is a y value. If x is here, y is up there. If x is here, y is down there. Okay? Now, what's the function? Let me give you another function. Actually, let me give you another relation that is not a function. Here is a relation that is not a function. Okay, don't forget, what is a function? A function says that each x value can be paired with only one y value. If that's not the case, then it's not a function. Here, example. Here's a relation. This is a relation. And it is going to be this. -1, 3. Note, I'm making up one relation, okay? And it does not come from an equation. I'm just making it up. 2, 4. 1, 5. 3, 4. 1, 6. Okay, so look at that. Is this a relation? The answer is yes, because a collection of order pairs. It is a relation. Okay. Is this a function? Well, let's see. Let's see. Is this a function? It is a relation. The question now is it a function? Well, let's see. -1 is paired with 3. 2 is paired with 4. 1 is paired with 5. 3 is paired with 4. Is that okay? Yeah, that's okay. So far, so good. And then, look at this. 1 is paired with 6. This one is paired with 6. Because the 1 is paired with 5 and the 1 is paired with 6, this is not a function. You understand? Not a function. It is a relation, but it's not a function. Okay? So this is not a function. Let's graph the scatter plot for this one. Watch what happened. Keep your eyes on 1, 5, 1, 5, and 1, 6. Keep your eyes on those two order pairs, on this one. And you'll see how they line up. Let's graph. -1 paired with 3. -1 paired with 1, 2, and 3. Right there. The first one. 2 paired with 4. 2 paired with 4. Right there. Okay. 1 paired with 5. And we're going to write this one in red, okay? This one, 1 paired with 5. 1 paired with 5. 3 paired with 4. 3. 4. So let me do this again. -1 paired with 3. -1 paired with 3 right there. Got this one. 2 paired with 4. I think I did this one incorrectly. Right here. 2 paired with 4. This one is 2 paired with 4. 2 paired with 4. Right there. I knew something was wrong. Got that one. 1 paired with 5. 1 paired with 5 right there. Got this one. 3 paired with 4. 3 paired with 4 right there, that one. Got it. And then 1 paired with 6. And this one, I'm gonna highlight 1 paired with 6. Look at this number, this order pair, and this order pair. What's going on? They line up vertically. And they call that the vertical line test. If a vertical line crosses the graph of a relation at 2 or more points, it is not a function. It is a relation, but not a function. So this one here is a relation, but it is not a function. Why? It fails the vertical line test. Vertical line does not cross a function at 2 or more points. If it does, it is not a function. And this one here, look. So it fails the vertical line test. Okay? I hope this is making sense, good class, all right? I hope this is making sense. All right. Let's graph the next one. So here is my question. Is x equals y squared a function? Well, let's graph it. Let's graph it. Okay. All right, very good. Graphic. Here is x, and here is y. If you want to make a table, you can, but once you make a table, you're going to realize you're going to see something. Table. X, y. Look at this. Y is being squared. So if y is being squared, I'm going to let y be values first. Okay. X depends on y. Whatever y is, x is going to be that squared. So if y is 1, what is x? 1 squared, which is 1. If y is 2, what is x? 2 squared, 4. If y is 3, what is x? 3 squared, 9. If y is negative 1, what is x? What's negative 1 squared? 1. If y is negative 2, what is x? What's negative 2 squared? X is negative 2 for y squared. Okay, so you can see it. What's negative 2 squared? 4. How about if y is -3? X is -3 squared. And what is that? 9. Wait a minute. Look at this. 1 is paired with 1, and 1 is paired with -1. It fails the definition of a function. It does. Because this x value 1 is paired with 2 different y values. Look. 1 is paired with 1, and 1 also paired with -1. So there it is. This is not a function. Now, if you want to see it if you want to see the graph, watch what happens. Let's plug in also 0. If y is 0, what is x? What's 0 squared? 0. So here we go. 0, 0. 1, 1, and 1, -1. 4, 2. 1, 2, 3, 4, and 2, and 4, -2. Oh boy. So you're getting this. And what's happening? It fails the vertical line test. This is not a function because it fails the vertical line test. You didn't have to go this far. You can see it here. 1 is paired with 1 and 1 is paired with -1. You can also see that 4 is paired with -2 and 4 is paired with 2. 4 is paired with 2 and 4 is paired with -2. Not a function. This is not a function, good class. Okay? All right. Okay. So this completes section 1. Okay? Thank you very much. Have a nice day, and I'll see you soon.